Find the general solution of the differential equation of e to the minus 2 root x over root x minus y over root x dy by dx is equal to 1. Okay, so let's write that out to begin with. All right, this can actually be solved by separating the variables. So separating the variables. Now, before we start, this does actually contain quite some difficult integration, so please don't worry, this is quite an advanced one. Right, so what I'm going to do, I'm going to write minus y over root x dy by dx is equal to 1 minus e to the minus 2 root x over root x. So what I've done, I've taken that over to this side. And then I'm going to have minus y, and then multiplying through by root x. So going to, for this one here, we're going to have root x, and obviously these root x's will cancel out. And then because I've got minus here, and I really want it to be plus, so I'm just going to do this. I'm going to write y dy by dx is equal, and with these two will swap round, e to the minus 2 root x. Now we achieved the objective of getting y on the left-hand side and x on the right-hand side. Now integrating both sides, and now you are actually integrating both sides with respect to x. So if we integrate y dy by dx is equal to the integral of e to the 2 root x minus root x, don't forget to put it in brackets, dx, and then that becomes the integral y dy is equal to the integral of e to the minus 2 x to the half minus x to the half dx. Now what we're going to concentrate on now is this bit here, because this is quite a difficult integral. So now just going to consider this integral, and we'll put it back to the equation. Right, this has to be done by substitution and then a bit of parts as well. So using substitution, okay, so I'm going to invent another variable. We're going to let t be equal to x to the half, and you know that you then differentiate that. So you're going to get a half x to the minus a half. Using your rules of indices, that becomes 1 over 2 root x. So dx will be equal to, making dx the subject, that will become 2 root x dt. Right, that now because root x is equal to t, we're just going to write that as 2t dt. So the integral of e to the minus 2x to the half dx will become the integral of 2 times t e to the minus 2t dt. So the 2t is here, and the dt, and then this is minus e to the x to the half, where x to the half is equal to t. So we changed the variable, but now we got to use integration by parts. So using integration by parts, we'll let u be equal to t. To differentiate that, you're just going to get 1 with respect to t, and then this bit becomes dv dt, which is going to be e to the minus 2t, which integrated is minus a half e to the minus 2t. If you think about it, you take that minus 2 down, going back again, you take that minus 2 down, so you get minus 2 over 2, which gives you e to the minus 2t. Pause the video if you're not sure about that bit. Right, so 2t e to the minus 2t dt is going to be, using the formula for integration by parts, uv minus integral of v du dt dt, where the original integral is u dv dt dt in this case. So that's the original integral. So that will give me 2, take that 2 out, we'll put it in at the end, uv, which is minus a half t e to the minus 2t, so there's v, there's u, so multiply that, minus the integral of v, which is that. Now, because we've got minus minus, it becomes a plus, and then the u by dt is equal to 1. So that's fine, so that will be equal to, now taking that 2 in, that will get rid of the half, so get minus t e to the minus 2t. And then when we integrate this, we're going to get 1/4 e to the minus 2t, which will make it 1/2 e to the minus 2t. And because this was a plus here, when we integrate it, we get a minus sign, so the whole thing becomes minus. All right, there's now a common sorry, we're going to substitute back t is equal to root x into that. So from the substitution, so we're going to get minus root x e to the minus 2 root x minus a half e to the minus 2 root x plus some constant c. There's a common factor of minus a half e to the minus 2 root x I'm going to take out. So that means I'm going to have a 2 root x here, and then a plus 1. It's plus 1 because I've taken out a minus sign. Again, pause the video if you're not sure about that. Okay, so going back to the original differential equation, which is this. Okay, so integrate y dy, it gives you y squared over 2. If we integrate this, where we just worked it out, so this bit is the bit in red here is this bit that we just worked out on the previous page. And then if we integrate this, we're going to get x to the 3 over 2. And we will have to divide by 3 over 2, which is the same as multiplying by 2 over 3. And we'll add in the constant. We only need one constant. Right, multiplying by 2 and taking the square root will give me this. So plus or minus the square root of minus e to the 2 root x plus 1 minus 4 over 3x, 3 over 2 plus 2c is the final solution. If we look at this GeoGebra app, okay, we can see here we have the case where c is equal to 10, a particular solution. And the slope field will give me lots of all the other solutions. So it's a solution of that differential equation that we had at the beginning. And we can move it here to get different values of c, okay? And I think eventually I did actually extend that further up. Okay, that GeoGebra app I will put in the notes of the video. I hope you've understood, and I thank you very much for watching, and maybe I could ask you to consider subscribing to my channel, where I have absolutely thousands of videos for A-level, IGCSE, GCSE and Key Stage 3, and my webpage will also be in the notes of this video. Thank you very much.